All right. So what we want to set up now is a way to basically say, let's run 96 of these frames at a low resolution sim and just use the last frame as our first frame in a higher res sim. Because we can obviously run a low res sim very quickly. We don't want to run, because by the end of this 96 frames here, it still hasn't completely resolved. Like we said, there's this like backwash stuff here and some other issues. But this is pretty good for a first frame. The high res sim will take, maybe 2 minutes per frame to simulate. So why not just get the general shape, the general velocities, way better than the initial just straight velocities and flat top. This is a much superior first frame. Even if this will be at a lower resolution, we can up-res it, essentially, more or less, in a very quick and dirty way, and we'll still give it 48 frames in the high-res simulation to further settle out. So the point is, we want to run our regular simulation at a low res and cache that, and then just grab the last frame. So the way we're going to do that is let's start here. Let's build this up in the low res way. So I'm going to go back to particle separation of 0.04, and here in the liquid source, we start the sim based on this initial state null here, which is again that flat top thing. So what we'll end up doing is we'll build a little thing parallel to it that's going to import the low-res simulation, rebuild the high-res particles, and then we'll switch between the two depending on whether we're running the actual high-res, which will use that, or the low-res, which is using what it already is. So, without further ado, dop import fields will get the sim. And yes, I know it's a little weird to have an import of a simulation in the source of the same simulation. Kind of weird. But that's why you're watching Applied Houdini, for weird stuff. So liquid sim goes into the dop network. Flip object goes into the dop node, because that stores all of the actual interesting simulation stuff we want. So if we plus this out here, we can start to grab stuff. Now I should note, you often will not see anything on the first frame. Although it looks like we're in luck this time. Well, I guess we're not. Anyway, what we want is the surface and the vel. So if we go to the second frame, hopefully we'll see something now. The velocity field never really looks good as a volume, so just make it invisible. It's still there, you just make it invisible. The surface should be an isosurface, because that's what sine distance functions essentially look like. And there you go. So now we have a couple of frames. Now we want, of course, the last frame. So I'm going to say, let's make a file cache to actually store all these. So a file cache, I'm going to call this the proxy sim, this low-res sim. The proxy sim needs a place to be stored. We're going to be doing a lot of caching of various things in this lesson. So we're going to set up this node one time and copy it around and give it some cool functionality. In particular, I want these files to be versioned, because we're going to be doing version 0, version 1, comparing them. So go to your controls node here, say edit parameter interface, get an integer, drag an integer into this controls area here, and this will just be a thing that we call version that will allow us to drag a little slider to be what version we want to read or write to. So back here on the file cache, now we've been putting things in terms of job, which is fine, except that it's going to put it on your main hard drive, probably, in your documents area, probably. And that's like, for me, I back my files up on Google Drive and stuff. I don't want to back these cache files up. And just in general, I have a fast disk for my operating system and then a bigger, cheaper disk for my cache files. So let's instead go to, if you have a data drive, I have mine on my E drive. So apply Houdini temp, I'll make a new folder called liquids to cache and something. So I'll finish it here. $OS means the name of this node. So when I copy and paste this node later and change the name, this will essentially update for me, which is really convenient. I'm going to do two of them. One of them, because I want it to be a subdirectory, and the other one just for the name of the file. Version, copy this parameter, paste relative references here. You'll see it puts these backticks. These are not apostrophes. These are backticks below your tilde key. That means that this is a string that will resolve into something within another string, which is what this is. Dot the current file or frame number dot bgu dot sc. So if we were to look at that and middle click it, you'll see it resolves to the name of this node, the version, and the frame number. I didn't lie. So another thing we want to do is set up these takes, or rather use the take. We've already set up and said the proxy sim's always going to use this lower res thing no matter what we have it set to otherwise. You know, if you're not familiar with takes, you can see how it's 0.02 here, but in this take it is actually this. We don't actually need to manually switch between these takes. We can tell things like this file cacher to just use that take. So when it runs the sim for us, it will use the lower res take. So let's let it do that for a minute. We'll save these to disk and look at the result in a moment. All right, that's all done, and we of course now have the, oh, it's trying to simulate again. Turn on load from disk. Cancel, cancel. There we go. So now we have that. There you go. We have a sim. So it's the 96 frame that we want. So we can put a time shift and say, you can either literally put 96 here. You could be fancy and do something like RF end, which is the end of this frame range here, or just F end. You know, you got options. All just ways of typing 96. So now if we scrub, it's just that frame. You can ignore that error. Cool. So now this is these dense grids. These are not VDBs. These are regular Houdini volumes. What I like to do is put a split here. You don't technically need to do this, but I think it's more intuitive. When we split, that means the volume named surface will come out of the left input and everything else will come out of the right. You can see there's surface. What we want to do is points from volume. We need to now recreate the points in here, or at least, again, this is how I like to do it, and say this is a signed distance field. We know what the particle separation is here. The idea here is we want to use the current particle separation. Now look at that crazy thing over there. We want to use the current particle separation to do this. We want to give it a jitter, where we just mess them up, much like the original. If you look at the original flip source, you'll see also jitter scale of 1 by default, just so they're not stacked in a grid. So now we have whatever, I'll turn this off for a second, whatever our current simulation is. Like, I plan on going as high as 0.05 later on. I needed to recreate all these points within that signed distance function. So now we have 76 million points based off of the shape of the last frame. So we'll go back to a mere 1 million points for now. Now they don't have velocities yet though, so we can use attribute from volume, like so. This will say all those velocity fields with a star, because there's 3 of them, make a velocity attribute from them. And now you can see we have this very pretty, swirly, you can see, no longer are these particles just saying smash into the rock on the first frame. They are already going to curve gracefully around the side of the rock. So a much better starting frame all around. And now we can say that, let's move these up, that is the starting frame for the sim normally, or let's say at least from now on. So we'll say switched, we'll make this be the switch where the initial state from now on is looking at that, but whenever you do a proxy sim, you should be looking at the other one. So include and take apparently 0. So whatever order you have them piping in. You can see this one is going into the 0th input. So again, in the proxy sim, if we needed to run another one later on, we could. And it will run from the regular flat top setup is what I'm calling it now. And our future sims, our regular, normal, maybe high-res sims, will run from this cool first frame. So that's pretty much it. Nothing else needs to be hooked up. The simulation itself already knows. I'll turn that back on. That's not actually a problem. That is just Houdini's weird viewport craziness, unfortunately. There we go. So on the first frame, as we can see, it now just looks like that. Now you can also see it kind of looks a little odd in the sense that there are a lot of particles, but just a very general broad shape. Well, that's because these velocities were based off of a much coarser simulation. So that we have the right amount of particles, we don't see as much velocity detail in here because we literally didn't have it. That said, we're still going to give it 48 frames to settle into this. Oh, weird. I hope I don't see that message every single time I do something. So annoying. So I'm going to run this, and now you can already see that the higher frequency velocity detail is starting to show up, and that's why we still want to have some pre-roll, even though we started from a nicer first frame. So I'm going to let this run, and then we'll take a look at the result. And here's the result of that. And now you can see, obviously from the first frame, even in the pre-roll area, it's already looking pretty nice. So again, you can see how it went from a very simple look based on the lower res sim, but then it kind of is able to sort itself out into the higher frequency look here. So I'm going to put 48 here. And 48 is not some magic number. I just happen to find that that's usually enough. Yeah. So there you go. So now everything is just moving forward. We don't have a backwash going back that way. I mean, even this churning area is still just, it's churning because there's colliders here and then here, but it's not moving backwards anymore. We don't have a wave that was literally, when we had this, it was literally moving up this way. I mean, we don't want to see that. So there you go. It's just moving forward, and everyone's happy. So that's cool. We did it. So now let's set up caching the actual sim itself.